control fields necessary to initiate a call with a cellular phone and get it up to a voice channel for doing testing. We use this capability in conjunction with the 11807 radio test software. We'll go through 11807 automatic radio test and cellular phone test in sections 7 and 8 of this videotape. Now that we've gone through the encoding capabilities of the 8920, we'll take a brief example of setting up the decoder for making a measurement on this tone sequential transmitter. We'll hook up the radio and go through the 3 steps for making a decoder measurement. Those are manually tune the receiver to the center frequency of the transmitter, manually hold the attenuator to the proper input level, and make sure that the de-emphasis network for your transmitter measurements is off. To step through those, go to the RF analyzer screen. We'll manually tune to the center frequency of the radio, 155.5 megahertz. We'll hold the input attenuator at 40 dB of attenuation, which is good for transmitters from half a watt up to 100 watts. Go to the audio analyzer and make sure that the de-emphasis network is off. That's what's necessary to set up the decoder. And now we'll go to the actual decoder screen to make the measurement. We'll choose the proper mode, which is tone sequential. Make sure that we have the correct standard, which is EIA for this radio. We'll make sure that the input level is correct, and we're actually expecting a 3 kilohertz signal from the radio. And we'll go up and arm the measurement. Notice that the status of the decoder is always displayed in the upper right corner. And now when I key the radio, we've automatically made the measurement. You can also use the speaker to rearm the measurement and listen to the tone sequence coming out. The symbol, the frequency error, on time and off time are all displayed for the tone sequential format shown. For each one of the encoding capabilities, similar decoding capabilities exist for each of the formats. As we mentioned in the introduction, the 8920 was designed to simplify and speed up your test and repair on your mobile radios. In this section, we're going to go through several of the ease of use features that we've designed into the 8920 to help make your testing simpler and faster. The first one of these is a save recall facility on the 8920. You can save an entire instrument setup in non-volatile RAM, and it will be maintained through power down using the save recall facility. Let's first hook up a radio and make a measurement very quickly. We'll do a receiver test on this mobile radio. Where we've quickly set up a SYNAD measurement. Using the save recall facility, we can store this entire instrument setup and recall it in less than a second at any time in the future. To save this setup, press Shift Save. Now what is displayed on the top of the 8920 CRT is an example of an alphanumeric entry field that we talked about earlier in the field types. By scrolling up and down in the list of ASCII characters that are available, you can even name your save recall register. So for example, I will select RX to name this receiver test. Press the Done key, and I've now created a save register for receiver test of my radio. From any other screen, for example, when I'm doing a spectrum analysis measurement, and I want to recall that instrument setup, I simply press Recall, and I have a list of the registers available to me. I choose receiver test, and in less than a second, the instrument setup is returned to where it was when I was doing that test. Many times while making a measurement, you want a hard copy of the test results that you've been making. Another useful feature of the 8920 is the hold and print capability. With an external printer connected, you can make your measurement on any screen on the CRT. For example, we'll look at the spectrum analyzer display of the carrier of this transmitter. I can hold that display by using the shift hold function to freeze the display even though the transmitter is unkeyed. And then I can use the shift print capability to dump that graphic image to an external printer. This is an example of the screen print that I did previously on a transmitter measurement for this radio. Several measurement and display functions have been included in the 8920 to make your testing easier. These are accessed through the data functions section of the front panel and include ref set, meter, and average. For example, any double-sized digital measurement can also be displayed in an analog bar graph representation. For example, such things as transmitter frequency error. To display that in analog bar graph representation, simply position the cursor in front of the measurement units field, kilohertz, press shift and meter, and you can label your endpoints, the low end, the high end, as well as define the number of intervals, as well as turn a meter on and off. So let's turn the meter on, and we'll get an analog bar graph display of the transmitter frequency error that was currently being measured in a digital readout. The digital readout is also displayed underneath in a smaller character size of the bar graph. For very bouncy measurements, to simulate the damping of an analog bar graph meter, we also have variable digital averaging. For example, on the frequency error, to turn that averaging on, hit Shift Average, key in the number of averages that you want, for example 15, and press Enter. A small annunciator underneath the measurement will tell you that the averaging is on, and you'll see now that the measurement is damped significantly compared to what it was before. Variable averaging is available from 0 averages all the way up to 65,000 averages so that you can simulate the damping of any analog meter. Another useful attribute is the reference set capability. You can use that capability to make relative measurements on any signal. For example, transmitter frequency audio response using the FM deviation signal. To make an audio response directly on the front panel, simply put the cursor in front of the FM deviation, hit Shift, Ref Set, and Enter to zero that, dB relative to the reading at 1 kilohertz, and then vary the audio frequency directly on the front panel until you can read the 3 dB points directly, 400 hertz. And approximately 3.2 kilohertz on this radio. The 3 dB points are displayed directly on the front panel, and again an annunciator is underneath that measurement to tell you that ref set is on. Many times it's useful to make settings on one screen and measurements on another. For example, setting up all your transmitter testing using the transmitter test screen, yet making measurements on the spectrum analyzer screen. To quickly toggle between these two screens, simply use the previous key to go between the last screen and the one that you're currently measuring on. If I select my spectrum analyzer to make my measurements, I can toggle quickly between transmitter test and spectrum analyzer in order to make those measurements. Another useful feature of the 8920 are user keys. To access any field without using the knob, you can use user-defined user keys from the front panel. These allow you single button access to any field without rotating the knob. To assign a user key to a field, simply position the cursor in front of that field, hit Shift, Assign, and the user key you want, in this case K1. And you'll notice now that there is a K1 in front of the RF generator frequency field. To assign a user key to the amplitude field, position the cursor in front of it, shift, assign K2, and you'll have K2, the user key K2, assigned to that field. Accessing those fields with one button is as simple as pressing that particular K1. Then you can enter or change that frequency. To move to the amplitude, simply press K2, and you'll move to that field and be able to change it or modify it as you like. There may be times when you'd like to change an instrument setting which is not contained on your current measurement screen. This is very common in stimulus response type testing. For example, varying the RF generator amplitude while looking at the distortion on your audio signal with the oscilloscope. In order to pull a control field to another screen, position the cursor in front of the field or setting that you would like to control, press Shift, Assign, Shift, K1 prime, and the 8920 will tell you that global user key 1 is assigned to the RF generator amplitude field. If we go to the oscilloscope now and look at the audio level, to vary the RF generator amplitude, simply hit Shift, K1 prime, and the RF generator amplitude control field will be displayed on the top of the CRT. Select that and vary the level to watch the amount of distortion on your audio input signal. When you've made the modifications to the setting, simply turn the cursor and the field will disappear. To get it back at any time while you're on that screen, simply hit Shift K1 prime again. 3 global user keys can be assigned at any one time to the instrument. A final user feature of the 8920 is an online help facility. By accessing the help screens, you gain access to up to 40 pages of user information displayed directly on the CRT to supplement all of the information contained in the 8920 operating manual. The 8920 contains a built-in controller that allows it to run automatic radio test programs on cellular phones, mobile radios, and other pieces of communications test equipment. Software allows you to run quick, repeatable test routines to characterize your radios. You can also get a test printout of the results to save as data or hard copy for detailed analysis. Test software is written in HP Instrument Basic or iBasic. You can create your own custom programs, or HP offers a wide variety of pre-written iBasic programs designed to test mobile radios, cellular phones, and other pieces of communications equipment. As an example, we'll run through a brief FM test package. The software is HP 11807, and we'll look at the FM test package, which is contained on a memory card, Option 1, North American FM tests. To run the iBasic program, insert the card in the memory card slot of the 8920 and press the tests key to get to the tests screen. The first step in running an automatic test is to define the test sequence and conditions and radio frequencies. This is quickly done with a procedure file. Before you load a procedure, let's take a look at the layout of the various test screens. For now, we're interested in the top third of this screen and several of the subscreens. From this menu, we can define exactly how we want a test to be run. As an example, select the choice Edit Frequency. In this screen, you can enter the transmit and receive frequencies of your radio for up to 50 channels. The other screens you can fill in are for defining the test sequence, specification limits, and radio parameters. While it's possible to fill in each of these screens one field at a time, you can save time by loading a procedure file. In the main test screen, make sure the procedure location is set to card. Move to the procedure field and select it, and you will see a display of any procedure files on that card. In this case, the default North American FM tests, which are shipped with the software. Selecting the procedure file shown fills in the procedure field and updates the test screen with program information and comments on this particular procedure. Now all of the submenus have been filled in. Looking at frequencies first, choose Edit Frequency. If the default frequencies don't match your radio, you can quickly update them to match. Enter the correct frequencies for channel 1, in this case 153 megahertz. Note that you can have separate transmit and receive frequencies, as in the case of duplex radios. Press Edit Sequence to see what tests have been defined.